on the video here. So this is an example of a linear equation. Remember, equation is an equal sign. Right here, we have seen this year. We've seen inequalities, but not linear inequalities. We've seen inequalities, but not linear. So what makes it a linear inequality is it's degree 1. Okay, so equations, if I was to say let x equals 0, for example, then if I plug in 0 right here, we would have y is equal to 0 plus 4, therefore y would equal 4. So we would have just one solution here. Does everybody see? But if I go over here to this inequality, if I said let x equal 0, that would be y values less than or equal to 4. That meets the criteria. So we would have 0, 4. What's another y value below 4? 3, right? 2, 1. So there are tons of solutions here. It goes on forever. So there are many, many solutions. Does everybody understand the difference? One solution, many solutions. So what we're going to be doing today is we're going to be graphing these linear inequalities. So this would read y values less than x plus 4. Y values less than x plus 4. This is actually quite easy, especially if you think of it the way I'm going to tell you to think of it as. So everybody, first of all, the first thing I would do is graph x plus 4. So everybody, look, I went up 4, and there's my y-intercept, up 1 over 1, up 1 over 1, up 1 over 1. And then I made my line. Now it's not including the line. Does everybody see? Not including the line. So I did a red dashed line. Then this literally reads, any y value below the line will be a solution. Did you see how it literally reads exactly how it's seen? Any y value below, because it's less than, below the line is a solution. So I go to the line, and what are the y values below it? All of these down here, do you see? So anything in the shaded region is a solution. This is just a way to show all the solutions. Graphing it is helping us see the solutions. Do you see? It's actually pretty easy, especially if you think of it like that. The only difference is this is less than or equal to. We graph the line just like we did above, and now it's or equal to, so it's just a solid line here. Does everybody see? But it still reads, any y value below the line is a solution. So these are the y values below the line. So now I'm going to ask you a question. On this one, is 0, 4 a solution? Over 0 at 4. But remember, this is a dotted line. So anything that falls on the line in this one is not a solution. Does that make sense, everybody? So this one would actually be a no. How about negative 5 up 2? Negative 5 up 2. Is it in the shaded region? So it's not a solution. How about negative 5, negative 4? Negative 5, negative 4 is in the shaded region. We all see. Okay, well let's answer this one then. Is 0, 4 a solution on this one? Yes, because it's a solid line. Negative 5 up 2 a solution. Nope, it doesn't fall in the shaded region. Negative 5, negative 4 is a solution. Just helps you see the solution. Let's do another one. Greater than. So same idea here. So this literally says any y value greater than the line is a solution. Any y value above the line is a solution. So the first thing I did was graph the line. So my y-intercept is down at negative 3. I went up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Then it's not including the line, so I did a dotted line. Then I read it. Any y values above the line? Well, look, that would be above the line up here. Those are the solutions. So question, is 0, 3 a solution? Yeah. Is 0, negative 6 a solution? Nope. How about 2 over 2 up 1? Not in this one because it's a dotted line. Dotted line, so no. Then right here, any y values above or equal to the line. So solid line, and then we could answer the same questions. Is 0, 3 a solution? Over 0 up 3, yes. It falls in the shaded region. Over 0 down 6. And then over 2 up 1, yes, because it's a solid line. Pretty easy, right? So let's practice graphing some of these. So it says graph the linear inequality. When we're graphing it, we're showing the solutions. So we got to get it in y equals mx plus b form. So let's subtract 3x. Now write it in mx plus b form. So we're really looking at this. Y values greater than negative 3x. That's a greater than sign, not a 7. y value is greater than negative 3x plus 7. Now you focus on graphing this line correctly. That's what you're going to focus on next. So our y-intercept's up 7, then we're going down 3 over 1. So down 1, 2, 3 over 1. And then is it including the line? Not in this one, so we would do a dotted line. Now look, it says, any y value above, does everybody see what I'm saying above? It's greater than. Any y value above the line. You see how it reads that? Y values above the line are a solution. So what's above the line? Isn't this below it? Well, then this must be above it. So all of these, let's do yellow. All of these are solutions. Everything that falls in this shaded region. I'm not going to fill it in, but you guys get the picture. So I'm going to ask you, is over 2 up 1 a solution? No, because it falls on the dotted line. Over 2 up, is over 2 up 4 a solution? Yes, it falls in the shaded region. We get it. Next one. So if you get it, then just watch, because there's nothing different about it. So just watch a few more examples. This one's in mx plus b form, so we're good. We'll just start graphing. Y values below the line. So let's just focus on graphing the line correctly. Down 2 over 1. Just watch to make sure when I'm up here it's so big that sometimes I mess up. So just watch carefully. Okay, it's a dotted line again. And it reads, any y value below the line is a solution. So below the line would be over here. Pretty easy. Doesn't get any harder than that. So let's get this one in y equals mx plus b form. The reason I'm doing this one is for a reason, to remind you of something. What in the heck? Sorry. So we're going to subtract 6x, subtract 6x. So right now I have this. Negative 3y is less than or equal to negative 6x plus 15. Then what would I do? Divide by negative 3. We just divided by a negative. We've got to change the sign of the inequality. The rules never change. So y values are greater than or equal to, changing the sign. You would want to split this up. Negative 6 divided by negative 3 is 2x. Then as long as we divide this by negative 3, we're okay. 15 divided by negative 3. Minus 5. So now we'll graph this. Up 2 over 1, up 2 over 1. Then this one is including the line, solid line. Then let's read this in order. Any y value above the line. So in this one, where would above the line be? Right there. Good. All this stuff is solutions. Now because it's a solid line, over 2 down 1 would be a solution. Does everybody see? Okay, sweet. Awesome. I think we're good with these. So just these last two to make sure that we understand how to graph this. Remember, if we graph y equals 3, that means y has to be 3 and y can only be 3. So go to y equals 3, which is right here, and y has to be 3. That's a straight line like this. Does everybody see? But this is y values larger than 3, not equal to. So you see how there's not an equal to sign? I need to put a dot. I needed to make this dotted. So I'll hurry and fix that. There we go. So now it says any y values above 3. So think about where that would be. What are the y values above 3? Up, right? Up. These are all solutions. But anything that hits right on the line because it's dotted would not be a solution. So over 0 up 4 is a solution. Over 1 up 4 is a solution. You guys see the picture. Get the picture. Okay, cool. How about x? We're going to need this to understand these ones for a little bit harder stuff in a little while. Any x value greater than negative 2. So everybody, x has to only be negative 2. That's right here, right? So this is the line that goes like this. Any x value values larger than -2. So it's or equal to, so I keep the line solid. So what are the x values above it? This way, right? X values that are greater than -2 would be all of these. These are all the solutions. Okay, cool. All right. So now, looking at this, we could solve this by graphing, because as you were able to see, if you have a graph, you can see all the solutions. That is one way of doing this problem. You could graph it and see which point falls in the solution set, or you could just use algebra. Algebra is going to be quicker. So look at how we could use algebra. It wants to know, is this point in the solution set? So let's use algebra. Look, these are x, y points. Let's start with this first point. Let's plug in x, y, and see if it's a true statement. So plugging in x and y, that would be 0 plus 3 times 1. Is that less than 6? Is 3 less than 6? Yes. So this one is in, if you were to graph it, it would be in the solution set. Let's plug in -2. So -2, 4. -2 plus 3 times 4, is that less than 6? So that's -2 plus 12 is less than 6. 10 is less than 6, no. So that one is not in the solution set. Plugging in 8 and -1. 8 plus 3 times -1, is that less than 6? So that's 8 minus 3 is less than 6. 8, 7, 6, 5. 5 less than 6? So if we were to graph it, this one would be in the shaded region. I'd rather just do it with algebra. Much quicker. Okay, great. So same thing here. If you were to do it by graphing, I'm just showing you could do it by graphing, then you could answer it by graphing. So let's say that I asked you and you wanted to do it by graphing, you'd graph it. Is over 2, -1 a solution? We could easily see it is. Over 1 down 3? Yes, it is, right? Over -5? Obviously not. So you can do it with algebra or graphing, I don't care how. Okay, this is my last two, I think this is actually the last example of this lesson. So, it's actually really easy, guys. These story problems are really easy. Let's read this. It says, Randy really enjoys Wendy's Junior Cheeseburgers and a Biggie Fries. However, he knows that his intake of saturated fat during the lunch should not exceed 16 grams of fat. Cheeseburgers have 6 grams of fat and fries have 3 grams of fat. It says, write a linear inequality that represents the function. So guys, we have a statement like this. This is an inequality. We have x and y. Those are different variables, right? So those are different aspects. Well, right here we have 2 different aspects. We have cheeseburgers and we have fries. So you're going to pick, call one x, call one y. Does everybody see it? It doesn't matter. So I am going to write it down. I'm going to say, okay, I'm randomly going with, let x be cheeseburgers. I always write it down, let y be fries. And then let's set up a statement to see how many of these he can eat. So think about this. There's 6 grams of cheeseburgers. So we have 6x. Because what if he eats 2 of those? Do you see how that'd be 12, everybody? We don't know how many cheeseburgers he's going to eat. But then he's going to also add in some fries, which have 3 grams of fat. We don't know how many, so 3 y's. Does everybody see how that's working? And that needs to be less than how much fat? 16. Is it equal to? Should not exceed 16. So isn't 16 okay? So we put an equal to sign. Look how that would actually make sense in real life. Like if you wanted to know in real life, you would probably not set this up. You'd just think about it. You'd calculate it. Can I eat 2 cheeseburgers and 1 fry? Well, 6 and 2, that would be 12. Does everybody see? You do this exact thing. So it says, can Randy eat 2 cheeseburgers and 1 fry? Let's plug it in. 6 times 2 plus 3 times 1. Is that less than or equal to 16? 12 plus 3 is 15. 15 is less than or equal to 16. Yes, we can eat that combination. How about 3? 6 times 3 plus 3 times 1. 3 cheeseburgers and 1 fry. Is that less than or equal to 16? 18 plus 3 is obviously not less than 16, right? He can't eat that many cheeseburgers. Easy peasy? Okay, sweet. I need to practice some of those right now so that we can do the bigger one when it gets a little more advanced. You gotta understand this to do the next lesson like really well. Practice, ready, go.